All right, vectors A, B, and C, D are shown in the standard XY coordinate plane below. One of the following is a unit vector notation of the vectors AB plus CD. Which one? Okay, so again, we are kind of combining these concepts of the unit vector and also vector addition. The good news is this is pretty straightforward. We are just going to break it down into the X and Y components. So what I could do, I wouldn't actually do this because it takes too long, but I'm just going to show you for the sake of this video. If I were to actually add these vectors, I would move CD here and I would draw it like that. And then of course I would get my resultant vector would be like this, right? However, if I was actually on the exam, I wouldn't do that. I would basically just, I would really just count, right? And I would kind of do this, really kind of imagine it in my head. So to get the resultant vector, I need to know how many units I'm moving in the x direction and how many units I'm moving in the y direction. So this vector going over from A to B, I'm going from -6 here to +3. So that has a length of 9, right? And CD, it's vertical, so there's no change in the x direction. So I already know my answer choice is going to be 9i, so I'm going to eliminate those. Now, pretty straightforward, even just using process of elimination. It's definitely not only one unit up, so I can immediately eliminate that. But just so we can show you exactly how we would get this answer, we could do the same thing going in the y direction. So now going from here, which is -2 on the y-axis, and going up to here, that's 4. So this distance is 6, and then the length of CD is another 5 units. Again, I really didn't draw this well. This isn't a scale, so bear with me there. You can just count the original length from here, from C to D. It goes from -2 to 3, showing that distance of 5. But then my total distance in the y direction, right, is that 5 plus 6, which is just 11. So that's how we got that 11J.